Hello, I'm Chuck Martin, and welcome to the Voices of the Internet of Things. With today is Rani Plaut, CEO and co-founder of Air. Rani has been CEO of Pulsar Limited, CEO and co-founder of Bmax, and CEO and co-founder of Polarity Mobile. At Air, Rani is focused on developing the mass usage of personal mobility through the air flying vehicles. Welcome here, Rani. How are you?
Thank you. Thank you for having me. Great
So
to be
you've
here.
been you've been doing this for some time now. What, 2017?
Well, the company was initiated by my partner and our CTO, Chen Rosen. He started it end of 2017. I joined at the beginning of 2019.
So did you expect it was going to take this long?
Frankly, yes. As an entrepreneur with many years on the road, it baffles me that even at my age, you tend to be over optimistic. But sometimes good things happen. So we thought it would take long, but we are always surprised that it's that long.
So tell me, for anyone who doesn't know, tell us what air is.
Well, as said, Ken, my partner, had an idea. He's an aviation guy. He started it as a way to manifest an idea, a patent that he had about having an extended range of a drone or a multicopter using a wing, but having low complexity. And he ended up with results that were much better than they were calculated or simulated before. I joined him first as an investor, and I got caught with a bug, let's say. I always do things that are thought to be impossible. And Chen and myself, we share the same passion for high simplicity and first principles. So, in essence, the company is trying to bring aviation to mass use. Many people are saying that, but we think we do it differently a little bit. In most cases, aviation stays in the aviation lane or the aviation path. And if you think about it, aviation and automotive were born sort of at the same time. So I don't know if you consider the first Benz car, it was 1883. We can call it the cradle of automotive. People tend to say that the Wright brothers was the cradle of aviation, 1903. And you can see that the evolution of those two industries are completely different. Aviation became a niche, a very specialized thing, high performance. Everything is the notch is turned to the maximum on everything, and price is relatively high, complexity is high, and the numbers are very low. On the flip side, automotive is a commodity. I mean, everybody has a car now, billions of cars. And if you think about it, there is not much difference between automotive and aviation. I mean, it's not normal to drive 65 on a highway in a 2-ton metal box with many other boxes right next to you. This is not, I would say, this is not weirder than being in the sky. So what we are trying to do, and this is the difference, we're trying to take the automotive grade technologies and processes and approach and implement it in aviation, but literally doing it. I mean, some companies, again, are saying that they're doing it. Some companies have been invested by automotive OEMs, but at the end of the day, they're producing an aircraft the same way aircraft are being produced. We're doing it in a completely different way, and we think that our approach is more viable and will spearhead the industry, basically. So it's about bringing aviation to very large numbers.
So, but doesn't the people who fly these, they have to have a pilot's license eventually?
Well, it's a ton of a device, so yes. But then again, a car is also something you need a license for. By the way, sports pilot is not so much more complex than a regular driver license. They both are at 25 hours range to obtain. So yes, you need a license, but for most vehicles you need a license. So that's not something particularly complex.
So when you look at the market, you're based in Israel, but you can basically sell all over the world. How do you look at the market in terms of where the opportunity might be, at least the beginning and then long term?
First of all, the big opportunity is in the U.S. This is by definition, U.S. is by any norm, the largest market. It's a unified 330 million people population. out of which the desire to be free and to do whatever you like is very strong. Financially, also, this is the most lucrative market. I mean, it's not that everybody's rich in America, but there is a very high proportion of the population with enough means to spend a couple of hundred, $300,000 on an aircraft. Many people own 3, 4, 5 cars. So the US is by far the biggest market. There is a fallacy. Again, other companies are saying, okay, let's go to the UAE, for example, or places where regulation is less stressful. But at the end of the day, the FAA and also the EASA, all the regulators are there for a reason. And the manifestation or getting to certification is about statistics. And the basic function of an aircraft, the first basic function is not to kill the occupants. The second one is having fun, but I think the first one is not to get them dead. And the certification process is there for a reason, and it's an accumulated know-how and an experience of many decades. So having shortcuts is not something that I advocate to in any case. Thereby, the US is the right place to start, and we are doing it differently a little bit but the US is by far the biggest market and the most interesting one.
So do you have manufacturing set up yet?
Yes, but it's a manual manufacturing site. It's still in Israel. We're moving it to the US in the following few months. Again, we're coming from automotive, so most of the critical components have been designed by tier 1 suppliers coming from the automotive sector. So our structure supplier is a German one. And if you look at the German automotive industry, they have been producing, let's call it 250 million cars per decade. So the accumulated know-how, the rivets, the riveting heads, the joining technologies, everything is very much matured. And we are riding the wave of low volume automotive production. In automotive, you have the hundreds of thousands per year, and you have the tens of thousands per year, and you have the thousands per year. But again, they're all using the same joining technology. So when you are designing a half a million car per year platform, it's a fully automated $1 billion facility. When you are designing something like the Audi R8, which was designed for 12,000 per year, you design it for semi-automation, but you can start doing it manually, and this is exactly what we're doing. So the line is designed to have partial automation, but we're starting the production in a very manual way using the same means of production.
Are you finding any particular demographic who looks like your early customer, the people who are expressing interest in these devices?
No, I always, when people are asking me this question, I ask, what is the typical user of an F-150? And normally it's a guy who wants an F-150. Okay, you can load it with hay stacks and take it in the field to feed your cows. You can use it in Austin, Texas, just because you want a big truck, you want to feel, you sit up there, you want to do some off-roading. So the demographics of the users, I would say the first characteristics is the desire to use the air for transportation, so wanting to fly. And I tend to say that this is more flying like Peter Pan than Chuck Yeager. So being in the air, not necessarily on the edge at 7 Mach. The second characteristic is having the infrastructure to use it. So you can't be in a highly populated area. You need to have a place to land at home and so forth. And the third, of course, is the ability to maintain it financially. It's not a very high tag price, but it is more than the regular car.
So you're also involved in the U.S. Air Force and the AFWorks program. Can you talk about that a little bit? I mean, that's very prestigious.
Yes, Agility Prime is a program that was initiated by the federal government and operated by the U.S. Air Force, AFWorks. Generally, the purpose is to propel eVTOL in general, to assist eVTOL to be introduced into the general population, not necessarily for defense use. Of course, when you're working with the U.S. Air Force, you are getting evaluated by the U.S. Air Force, and you are exposed to the DoD in general. But the essence of this program is not defense, although we do some defense applications. The three big other names that are in this program are Archer, Joby, and Beta. Elroy is there, Lyft has been there. We're very happy to be the fourth or the sixth OEM and the only one which is not American based. During this program, you start with an evaluation of a few tens of hours. There is no quote unquote defense contamination of the company. So the relationship is done in a very, very neutral way. They are not dictating anything to the OEM in terms of what to do, how to do, or how to design the aircraft. But still, there is some access to the DoD, to the technologies that are being developed. Again, as you mentioned, it's very prestigious, and we're very happy to be a part of it.
So in terms of where this goes, you now have a cargo vehicle you've just announced. Is that a whole different approach or different business?
Well, I'm a 57 years old entrepreneur, so I tend to. My wife says I should know something by now, and what I have learned through my not so few failures and a few successes is that you have to listen to the market. At the end of the day, it's your idea, it's your product. You have a concept of what it should do, how it should be sold, what's the business concept, and so forth. But it's also very important to listen to the market. And once you have traction and you have happy customers that are willing to pay, if it's a group of that you can characterize and address, it's very good to either pivot to it or use it. Now, when you test an eVTOL, by definition, you start doing it unmanned by remote piloting because you can. When you do a 737 or an Airbus 350. It has to be piloted from the get-go. An eVTOL can start flying remotely. It's a big drone at the essence or as a concept. So we started using it as everybody and in remote piloting. On top of that, our flight control system is highly patented and highly autonomous or automated, meaning the aircraft can take off by itself, land by itself, pick up a landing site by itself, fly point to point by itself, and avoid some obstacles. So this is what we did just in terms of testing and clocking hours for the manned applications. Now, since it's a very small club, the people that are actually flying in full scale, Joby are flying, Archer has just transitioned, Vertical are flying, Volocopter are flying. I think it's under 10 the number of companies that are actually flying with full scale, full weight prototype. So once you get to the air, you get people's attention. The market is very noisy. If you Google it, you'll have 800 different eVTOL companies, but again, less than 10 are actually flying. So we have been approached. We started flying at June 22. We have been approached by at least 8 large customers, including Agility Prime. This is not a customer, but a program. But we caught people's attention. And last year, one of those people, after a long evaluation, just placed a check, a purchase order with a down payment for the first unit. We delivered it at the end of last year, 23. And after 4 months of very rigorous testing, they have ordered 10 more. And as you can imagine, it's a sizable amount. On top of that, we have another customer that have ordered a first of many other aircraft of 2 prototypes for this deal is a $3.5 million deal. For a startup with 50 people like us, these numbers are serious. On top of the fact that this is a customer that pulls you into the process, enables you and enforces some rigorous testing. It's the same unit, so the same structure, lacking the occupant-oriented equipment. So the seats are not there, the stick is not there, the screens are not there, and the automated functions are becoming productized rather than a utility for the testing. So this is a gap, but it's not a 50% gap. This is a 10% gap. And we thought that this will enable us or assist us in clocking hours, that cannot be counted for the manned aircraft, but certainly can prove the structure, the aerodynamic surfaces, the behavior, the flight control system, and so forth. And in general, my concept is trying to use the path of least resistance to achieve your goal. And this is by definition a much lower path. Again, it's not like you can fly over Zurich or Manhattan, with this vehicle. But in cargo applications, there are some rural areas applications where you can clock hours in real life scenario, thereby obtaining a very, very high, I would say, advantage over other competitors, and proving ourselves that the thing is safe.
You mentioned that these are pilotless when they start, and you've got companies like Ehang in China and Whisk is developing in that direction. Eventually, do you see these vehicles, not just yours, but just in general in the industry, do you see the vehicles as pilotless long term?
My answer would be no. People don't like putting their fate in machines' hands. You see it on the road. It has been it has been in 2 years for a decade now, and I think it will be in 2 years for the next decade on the road. Now, there is some gradual growth, but it never comes to full autonomy. I think the air is even more complex. It's not that unmanned things are not flying for 3 decades now, especially in defense applications. But for the regulator to put people's fate in an autonomous vehicle, I think it's a very, very high step to take, especially when you have a completely new platform and configuration. The regulator is moving in small steps for a good reason. And you never start with an autonomous Airbus A380. You start by a piloted Piper or a Cessna or even smaller. So we think that this jump is very good for hype and for raising money. But we think that it's a very long ways now. It's a good point for Boeing to tackle, because Boeing can wait 15 years. But again, I think that before the FAA and EASA will let Boeing truly fly and provide service, they would like to see tens of thousands of hours of the configuration in the air. And the configuration is a powered lift electric vehicle, which every word and every aspect of this new animal, so to speak, is completely new. It's a fly-by-wire, which is a thrust or vector thrust based aircraft. It's a multi-motor configuration. The transition is a big challenge. Not for us, for example, we have a patent on very high simplicity, but most of them are doing a very, very complex transition. So every aspect should be proven. And if you go to commercial applications, it has to be proven to 10 to the minus 9 in most cases, which is a very high bar. So if you look at the process of obtaining the FAA certification for the Airbus 350 or the 787, it shouldn't be something shorter. And maybe even longer. Having the 787 is just quote unquote yet another airliner, same as the 747, 737, and the rest of them. This is a completely new animal, so we think it's going to be a very long while.
So how do you see the market over time evolving? You've got the ultralights, of course, which are some of which are shipping now. Then you've got the certified vehicles like the one you're developing, and then you've got the air taxi type vehicles. How do you see it over the next, say, 5 years developing in terms of the trends and what's first and so forth?
Well, first of all, we see it very clearly, and maybe we're stupid because everybody else is seeing it otherwise. We think we see it the right way, and we don't get why the others don't see it that way. We think that the Part 103s, Jetson for one, the opener for another one, very serious companies, they don't want to see dead customers either. So they are going through all the statistical verification, but they don't end up with a certified aircraft. On the flip side, what I said before about the lengthy process of a type certification for commercial use, it is what it is. It's a very long process. So we think that the middle ground, in order to show the public, the regulator, and the insurer that it's safe, you need to clock hours on a certified way, on a certified aircraft, which is not what you may call non-type certification. And these are, you have those in experimentals, you have EABs. We chose to try and get into the Mosaic project under LSA. LSA or Part 22 we consider it to be the highest stage under full type certification. We have an application for type certification under 2117B, so powered lift, but this is something that will take longer. We think that the cradle of the industry starts with light sport applications or light sport aircraft. The Mosaic project expands LSA to having non-direct flight control or what people call fly-by-wire, differential thrust, multi-motors, electric aviation, and so forth. And we think this is the right way to go because this is a self-declared kind of certification. It's very streamlined. It's there for, I think, 12 or 15 years. It has been proven to be safe. But yet again, the bars are not too high for companies to obtain. So we think that this is the first step. This is the first evolutionary step of getting those things in the air. We think the 103s are great hobby or leisure type of things. At the end of the day, leisure is dictated, among other things, by the fact that you start and finish at the same point. If you start and finish at different points, and at some point somebody will say, "This is not leisure. This is commute." So we are trying to play by the rules. We're trying to change what we can in terms of our contribution to the committees of the Mosaic. The NPRM was released last July, which means we can probably be releasing aircraft in late 25. And we think this is the first step. Now, this does not contradict the commercial guys. We think it paves the way to the commercial guys. And we think this is better than the 103s because, again, the 103s are doing the same statistical verification because they want live customers. So we think the middle ground is light sport applications or EABs or experimental. And we hope to see other companies doing it. We can do it because of our patent of simplicity and the ability to do it in automotive grade, so large quantities. We hope others will follow us.
So if we're sitting here a year from now talking about the same subject, what will we be talking about? The end of 2025?
Well, we have close to 20 aircraft ordered, purchase orders. This is not letter of intents from airliners and so forth. This is actual purchase orders with down payments. We finished last year with over $1 million in revenues. We'll finish this year with $6 million in revenues. In 25, I hope to pass the $15 million in revenues. I think that in 25, we will be able to show over 25 aircraft in the air with customers on the cargo section. We think it's a very large contribution because people needs to see those things in the air, flying electric. That's the new thing. And we think that by the end of 25, you'll see 25 to 50 customers of our 1,200 registered customers starting to fly in the US, Austin, Texas, Utah, Florida, and such places. And we think this will break the membrane, so to speak, in trying to propel the market.
Well, I look forward to that conversation. Thank you, Ronnie, and thank you all for listening to the Voices of the Internet of Things. I'm Chuck Martin.
Thank you. Thank you very much.